Welcome to Chibuzor Mathphysics. In today's video, we want to look at what exactly is microwaves, and we're going to talk about where can we find them. Microwave ovens. We are going to talk about microwave ovens. We might also talk about absorptions of microwaves. We talk about absorptions of microwaves by food. Concerns about microwaves that are raised by so many people. That is concerned about microwave turning food. When you talk about radioactives that are baselates, the radiation in the microwaves. So we are going to look at all these things in details. I remain your host, Augustine Galagash. So you have to stay tuned, and at any point in time, you can pause the video and try to listen and go through them again. So let's get started. Looking at the microwaves radiation and then the infrared radiation. Of course, these are second and third group in the electromagnetic spectrum, and this is what we'll be looking at. So we are talking about the long wavelength and the low frequencies. We know we have both the long wavelength and the low frequencies. So microwaves will lead us to so many things. And of course, we have what we call the aren't absorbed by water molecules and those that are absorbed by water molecules. So there are parts that is absorbed by water molecules and those that are not absorbed. So another application of those that are not absorbed is the searchlight. Of course, it has to pass through the atmosphere. It passes through the atmosphere when we look at the searchlight. This is what you find through the searchlight. Of course, it received and transmitted. It is a kind of a satellite dish, and this is exactly what we talk about when we are referring to microwaves. So if you talk about absorbed by water, now this refer us to microwave ovens. Of course, we heat our food as we normally do at home. You see, we use microwaves at home for our own day-to-day activities and to meet up to our needs. So it is absorbed, and what we mean by absorb is that it starts to vibrate more, so there is a transfer energy to nearby molecules, so spread throughout the food for conduction and convection. And this is exactly what I would like you to pay good attention to as we go through this video. So generally, like we are saying, microwave is an electromagnetic wave with a wavelength between 1 millimeter to about 1 meter. So microwaves at the speed, it moves at the speed of light, which is 300,000 kilometers per second through empty space. So you have to note that these travels are in 300,000 kilometers per second through empty space. So here we have in the distance. Of course, the things you have to pay attention is that when dealing with microwave, you have to pay attention to the amplitude and also the wavelength. As you can see, the distances between the trough and the crest is shown by the arrow as indicated by each wavelength. So we have to pay attention to this, and this is what we'll be talking about. But the things that you have to note here is that microwaves moves at the speed of light, and this speed of light is around 300,000 kilometers per second, but it has to go in an empty space. So the frequency of microwave is between 300 megahertz. This MHM meaning it is megahertz. That is 0.3 gigahertz up to 300 gigahertz. So microwave, including wave with the super higher frequency, is included in this range. And let's see how that goes as we go through this. Before we proceed, I would like to introduce the formula for this, because as you know, when we are dealing with this physics, it is very crucial for us to pay attention to calculations, because we are going to be using this formula. D is equals to C by delta t, that is the change in t, the small change in time, divided by 2. Of course, d meaning the distance, c is the velocity of the wave, which is always given by 3 times 10 raised to power 8, as we all know, and this delta v is just the difference in time, and it is in seconds. So we have to pay attention to this, as it will be required in computations. When I was actually trying to search about microwave, what comes to my mind is how did this microwave come about? It is good for us to pay attention to that. So I decided to bring this to our notice. The inventors of microwave, in the 15th-year-old James Clerk Maxwell was able to present scientific paperwork. Maxwell considered the greatest the theoretical physics in the entire period between Newton and Einstein. So Maxwell is a scientist who has been tracing the link between symptoms of electricity and magneticity based on the knowledge that already exists at the time. Of course, all of you here can be a witness. That's why we are asked to derive Maxwell equations. Of course, we know all those equations, and Maxwell disagreed with one of the equations, that is the amperes. And in another video, we're going to be talking about why did Maxwell actually disagree with the amperes law. But now, these young men were able to come up with something that is strategic. Not only strategic, symbolic, and not only symbolic, it is something that is very helpful for us to do our computations. And I'll tell you why in a second. Let's keep going. Of course, we have another gentleman in 1864. He proved that electromagnetic waves are a combination of oscillating electric and magnetic field. We are still with Maxwell. Maxwell found that light is a form of electromagnetic radiation. He also opened the understanding of the motion of the gas by showing that the rate of the molecules in the gas depend on the temperature respectively. So what you should pay attention here is that the rate as Maxwell could have it, you could pay attention to the rate of the molecules in the gas. So according to you, what amount of rate of the molecules in the gas that you think that are most that we should pay attention to? So these molecules in the gas depends on the temperature, and this temperature is going to be proven later by another scientist. And this is why the beauty of science is that we don't just remain opaque, as we know in this town. Most of the times we talk about the opaqueness of some laws, the opaqueness of some theories, the opaqueness of what we have come to believe. So we don't need to be too opaque. We, as scientists, we are very open, and that's why we do research. That's why also we tend to investigate and find systematic approach of handling questions. So even you today that are seeing this in this class in Tangaza University, I challenge you to also do investigation, do your own research, and maybe you can provide solutions, and maybe you can come out later after some years and tell us that Maxwell equation is opaque, and then if you are able to prove beyond reasonable doubt that your opaqueness is real, we will have no other choice than to believe you. Otherwise, let us continue. So many other people that talk about microwaves. This is Heinrich in 1888 who was the first to demonstrate the existence of radio waves by building a spark crab radio transmitter that produced microwaves with frequency 450 megahertz. Of course, these radio waves and microwaves, all of them work hand in hand, and we'll be talking about all of them in today's video. We know that we have another gentleman, Jagdish Chandra Bose. He showed radio control of a bell using wavelength and researched microwave propagation. We have also Albert Wallace, who invented magnetron as transmitter of electromagnetic wave, and so many other things. So I would like us to see what are the applications of this in daily life. We have Wi-Fi. As you know, in this school today we are using Wi-Fi zone. We also have Bluetooth in our phone. We have waveguide like what we have in our houses when we have our heater microwaves that we use to heat our food, and it gives us a good sense and of living a good life. So let's also look at microwave oven. This is a component which is designed to arrow the microwave to food chamber. We also have electric energy in charge to the microwave radiation, and we also have a lot of other applications, as you can see. So a microwave oven is a household appliance that is highly efficient and energy saving. The working principle of oven is a microwave. Like we know, magnetron is the oven produces microwaves with a frequency of 2.45 gigahertz. We also have microwaves from the magnetron, which is directed into a waveguide. We have the waveguide forward microwave to a device resembling a fan called Stera, and many of them you can pause the video and try going through this yourself so that you are able to get what we are talking about. So a microwave radiation of microwave oven and some radar application is produced by device, and that device is called magnetron. It is called magnetron. So these things are very important in our day-to-day activities, and I challenge you, even as you finish watching this video, to go do your own research. Maybe you can come up with something that is more brilliant, but not only brilliant, something that is able to convince the scientists that you have proven beyond reasonable doubt that whatever you are talking is not just opaque, but it is reality. And finally, I would like to conclude by saying that microwaves, including waves with the super high frequency, this wave is very beneficial for human life in various fields, especially in the field of communication. And you have seen that microwave is not just important in the field of communication, even in our day-to-day life, as we use them in our house, for domestic use and for other purposes. I think this will be the end of this video, and in the next video we'll continue with computation. I remain your friend, Augustine Galagash, and if you are joining us in this video, don't forget to click on the subscribe button and subscribe to this channel. As you do that, write your comment on the section below and I will give you feedback. Thank you and God bless you.